All right, good morning, everybody. Hope you've enjoyed the conference so far. I'm Michael Washam. I'm a technical evangelist on the Windows Azure team. And in this session, we're going to talk about monitoring and troubleshooting Windows Azure applications. So for the agenda, we're going to actually kind of do a deep dive into Windows Azure Diagnostics and how you can use it to monitor your applications. I'm going to introduce a lot of brand new functionality we've added to the Windows Azure PowerShell commandlets. So if you're new to PowerShell, this will be a good introduction. If you've never seen Azure PowerShell commandlets, this will be a really good introduction. We're going to do a lot of deep dive configuring and analyzing diagnostic data. I have a sample app that I'm going to take from beginning to end to show you how diagnostics works. And we're going to end the session by talking about some general debugging and troubleshooting tips for Windows Azure apps. Okay, so what exactly is Windows Azure Diagnostics? It's a distributed application monitoring and data collection system that basically allows you to choose what kind of diagnostics data to collect and when you want to collect it. So you can capture event logs, trace logs, perf counters, IS logs, etc. It's cloud-friendly, meaning you can manage multiple role instances at the same time. You don't have to go manage them individually like you would with an on-premise solution. It's scalable, it's backed to Windows Azure storage, and best of all, it's remotely configurable. So bet most of the code samples you guys have seen for configuring diagnostics has actually been all during the worker role. We actually expose a lot of functionality where you can actually completely manage your Azure Diagnostics remotely. And keep in mind, Azure Diagnostics is not a replacement for outside-in monitoring. So it'll tell you everything that's going on inside your application, end-to-end, but between your service endpoint and your user, it's not going to give you any insight other than maybe they're not connecting. So an external monitoring system is always a good idea. Okay, so just to kind of compare and contrast why Azure Diagnostics was designed the way it is, I'm going to show you how the typical single server on-premise solution versus how you would monitor a cloud solution up in Azure. Single server, you have basically a really well static environment, know everything that's on there. If you need to download a debugger, you can put the debugger on it, you can start up perfmon, you can look at your event logs. Everything's pretty much local, and if you're really brave, you can actually make an in-place change and hope for the best that it actually worked. Cloud's a little different. It's a dynamic environment. You're going to be working with multiple instances. One day you may be working with 4 instances, and the other you may be working with 8. So that's elasticity. The workloads are going to be distributed. So instead of having everything all on one machine, you could have multiple roles. You could have a web role, a worker role, etc. And all of this kind of makes local access infeasible. So just think of the scenario if you have 10 worker roles, 10 instances running, you're crunching numbers out in the cloud, and one of them crashes. From a debugging perspective, which one do you actually go out and log into to see what happened? So that all this just makes it really hard to debug it using traditional tools. So how does Windows Azure Diagnostic work? When your role instance starts, the diagnostic monitor, which is an agent on your instance, actually starts at the same time. From there, you can configure it to tell it what all to log. You can do it when your role starts, or you can actually configure it remotely at any time. Once the diagnostic monitor starts and is initialized, it actually saves all its configuration out to blob storage, basically as a big XML file. Once it's configured, it starts monitoring whatever you told it to monitor, and it actually buffers this data to the local file system. You can set quotas per data source, so you can have really granular access on how much disk space diagnostics takes. But it actually is on the local file system for every instance in your deployment. So to get access to this, you need to transfer it out to Windows Azure storage. And there's 2 methods to do that. You can have a scheduled transfer, which basically means move your IS logs out every 30 minutes and your application logs every 15, just an example. Or if you're in the middle of a debug session and you need to look at the data immediately, you can actually make an on-demand transfer so you don't have to wait for the schedule. So remote configuration, just to kind of give you an idea of how remote configuration works. Like I said, the diagnostic configuration is actually stored out in Windows Azure storage. So the first thing you as a user would do using the diagnostics APIs would be to retrieve the current configuration of diagnostics. You would make your changes, tell it, monitor trace logs, monitor application logs, whatever you need to do. Then you would actually save that back up to Windows Azure storage. The diagnostic monitor pulls storage every minute looking for changes to the configuration, and assuming it actually finds any, it will apply them out to the diagnostic monitor and do the next, do whatever you told it to do. So this is just a table that shows you where the data sources, the data sources that you monitor, where they actually end up in Windows Azure storage. So your event logs, perf counters, Azure logs, and infrastructure logs all will end up in Windows Azure table storage. Any kind of log files like from IS or failed requests, crash dumps, those will actually end up in blob storage in their own containers. So to configure diagnostics, like I said, you can actually programmatically enable diagnostics in your worker role on start code. You can tell it everything you want to log, when to transfer it over, and pass that all in as parameters to the diagnostic monitor.start method. If you're using Visual Studio, there's actually just a checkbox per role to enable diagnostics. You check the checkbox and specify your Windows Azure storage account. This is basically where it's going to transfer all the data to, and that enables diagnostics for that role. Now, configuring diagnostics is a little different. There's multiple ways of doing it. Like I said, one way would be the diagnostics monitor on start. There's actually a role instance diagnostic manager class that allows you to manage everything remotely. And there's actually a declarative method to do this as well. So if you're using VM role especially, since they don't really have worker role on starts, you can actually configure diagnostics all through the diagnostics.wadconfig. You specify that, include it with your role, and diagnostics is configured whenever it's started up. And finally, we have lots of different tools out there available to define diagnostics. So one of the tools built by my team is the Azure MMC. It allows you to configure diagnostics. If you have System Center, Operations Manager has a Windows Azure Management Pack that gives you end-to-end monitoring and diagnostics management. Third-party company named Cerebrata I'm going to show a short demo of their diagnostics manager today. Is a really good tool, and there's tons of other partners. And finally, the Windows Azure PowerShell commandlet. So I'm going to show a lot of that functionality today, and we actually just shipped it moments ago, literally. So if you look up on the Codeplex site for it, and I have a link at the end, we updated the PowerShell commandlets to 2.0 and show you some of the new functionality there. So just to throw out some of the different examples of how you can configure diagnostics. This would be one of the examples of configuring diagnostics during role startup. You would call the get default initial configuration static method of the diagnostic monitor class. This is basically a blank slate, returns back a configuration with no settings in it whatsoever. From there, you actually configure the different data that you're interested in. So here we're telling it we want to capture application logs from the Windows event logs. We're going to tell it to transfer only errors. That second property is schedule transfer log level filter. So you can tell it to transfer everything, or you can only look at the more interesting events. And finally, the scheduled transfer period that's telling it to transfer Windows event logs out to storage every 5 minutes. And finally, we start the monitor. Other methods, this is if you're writing an application to actually configure diagnostics for Windows Azure, if you're an ISV or you're just a developer that wants to manage it yourself, you would use the role instance diagnostic manager. You do that by creating your cloud storage account, initializing a role instance diagnostic manager. There's actually a deployment diagnostics manager too that's a little easier to initialize this with. From there, you call the get current configuration, so not the blank slate, it's whatever was set the last. Make your changes and set that configuration. Okay, so I'm going to go a little deeper dive into the different properties of what you're configuring so you understand more of what they mean. So some of the common properties of the diagnostics configuration are the overall quota in megabyte. Basically, this is the top level quota for all of diagnostics. So you can basically allocate a certain number of megabytes, gigabytes, whatever, and give it directly to storage to manage. For each data source, application logs, trace logs, perfmon, et cetera, you can also set an individual quota. You can also leave that at 0 and just let the overall quota manage it. Scheduled transfer period in minutes. Every data source can be set distinctly. So you can set each of them to be on their own schedule transferred over to storage. Some of the data sources, such as event logs, Azure logs, and infrastructure logs, actually support a log level filter. So like I said, you can only transfer over errors, informational warnings, or whatever you're interested in looking at. And finally, some of the data sources, such as event logs, perf counters, and directories, actually have a concept called subscriptions. They're just basically further information that you need to define for that data source, such as which event logs to log, which perfmon counters, and which directories to monitor. So let me introduce you to some of the new functionality we've added in PowerShell commandlets for Windows Azure. We've given you the ability to actually download the diagnostic data directly. So this kind of goes in a really good pattern. You'll be able to see after you see the rest. One of the additional features we've added is whenever you download the perfmon counters, you can actually convert those directly over to perfmon's binary log format. So if you're used to analyzing perfmon data in perfmon and getting charting and all that good stuff, we now have the capability to do that. The rest of the data is going to be downloaded as either a blob, if it's a log file, or CSV. So you can still parse it in Excel or PowerShell, however. We've given the capability for PowerShell to delete and clean up all the diagnostic data. So previously, you've been able to configure diagnostics and actually have it log out to Windows Azure Storage, but you had to write code if you wanted to go back and clean it up. So now you can script it, pretty simple to do. And another new functionality in the 2.0 release that we're not really going to cover today is the ability to script and automate, delete, remove, add hosted services, storage counts, affinity groups, SQL Azure, storage analytics, and actually download data out of storage containers. So the goal is to be able to, just with PowerShell alone, give you the functionality to automated deploy your application, configure diagnostics, download diagnostics, clean diagnostics, kind of an end-to-end lifecycle approach. So if you're new to PowerShell, let me introduce you to how you can actually use it with Windows Azure. The first thing you need to do after you actually download and install the commandlets is add the PowerShell snap-in WAPPS commandlets to your script. That actually stands for Windows Azure Platform PowerShell commandlets. From there, you would call the get hosted service commandlet. You'd pass the service name you're interested in managing, your management certificate, and your subscription ID. And the pipe operator at the end basically tells PowerShell to take the return value out of get hosted service and pass it to another commandlet. So we're taking the results out of get hosted service and passing it to get deployment. Get deployment says, okay, you're working with this hosted service, which deployment do you want, staging or production? From staging or production, you pass that to get diagnostic where roles, and it actually needs your storage account because at this point we're working with storage doing diagnostics. And get diagnostic where roles returns back a collection that you can enumerate through of all the different roles that you're working with and actually set the different aspects of diagnostics on them. So if you're not used to that little $_ operator, what that is a PowerShell operator that tells it, that's basically represents the current object in the for loop you're iterating through. So I have a sample application called, in this deck it's Contoso Mortgage. It's actually Woodgrove Mortgage. But in this example, we basically have 3 roles. We have a web role, ASP.NET front end, that has some logging requirements, tracing, Windows event logs, IS logs, and perfmon. We have a couple other roles. One is a native service that generates mortgage rate quotes. So it tells a customer how much, what rate they would qualify for a loan. And it's run entirely native code, so it's not running in IIS. So we're going to enable tracing, event logs, and perfmon. And finally, we have a worker role running in said WCF service that generates good faith estimates as a PDF service. So the logging requirements for it would be everything that's needed for IIS, plus we're actually enabling some WCF logging as well. So we're going to configure custom logging for this service. And finally, the results of this service go out to Windows Azure Storage. So I'm going to enable storage analytics so we can actually see more detail how our application is using storage analytics. Since we're migrating this app out to Windows Azure, our project manager says, we have some existing bugs that we'd like to get tracked down since we're actually configuring diagnostics. So they've given us some screenshots that have been reported. So one of them is we got a yellow screen of death from the referafriend.aspx page. So our boss has said, we really haven't had a chance to look into this before. Since you're configuring diagnostics, let's get it tracked down. And we get this one as well occasionally. This is a user goes to request a quote, and they get a no response from mortgage rate service. Don't know why, no idea. So we're going to use diagnostics to track that one down as well. And finally, the last bug that we're going to track down is occasionally whenever they fill out the request quote form, the monthly payment comes back set to infinity. A little bit steep. So let's go ahead and start with a blank application, or not a blank application, but an application with absolutely no diagnostics. All right, so let me just show you what the app looks like real quick. This is in our staging environment. So normally, a customer can come to the Refer a Friend page, fill in their information, and one of our customer service reps will call and harass them to get their business. They also have the capability of filling out some personal information and getting a mortgage quote. So it's actually calling out to the service and getting that. They can also save this quote out as a PDF file. So this is basically the application we're going to try to diagnose. So the first thing I would do if I was migrating this application out to Windows Azure is I would go into each role. Actually, let me start to zoom in real quick. I have 3 roles here: the mortgage rates PDF generator, the mortgage rate service, and the web project. I'm going to go in each one of these and enable diagnostics. And you enable diagnostics basically on the property sheet by checking enable diagnostics and specifying a storage account. By default, it's going to go to the developer fabric storage account, so you do not want to leave it there if you're going to try to deploy it out to the cloud, because your application will not deploy. So let me change all these over. Okay. Now that all the applications are actually enabled for diagnostics, we've configured a storage account string, we've added the diagnostics module. The next thing we want to do is enable all of them for enabling tracing out to Windows Azure Diagnostics. If you create a new cloud project in Visual Studio today, this will actually be added for all your projects. But since it's a migration, we're going to have to add it ourselves. So what I'm going to do is there's a Windows Azure trace listener that basically plugs in anything from .NET Diagnostics, system.diagnostics. It actually funnels that information into the Windows Azure Diagnostics system. So all I have to do is in each of the configuration files, add a little snippet of XML that references a trace listener. Okay, so I'm going to do that for all 3 of our projects to enable tracing, even our worker role. And the last one is going to be the PDF generator, this WCF service. Now, the WCF service has some additional logging requirements. It has its own listener, its own custom trace listener that basically logs to a file in the file system. So we're going to have to actually come back and configure that here in just a bit to make it work correctly. So I'm going to go ahead and add the Azure trace listener inside of diagnostics. And we're set. So now that we're set up for doing tracing in Azure, I'm going to go ahead and actually add some tracing around those 3 problem areas that we were looking at. So in the refer a friend code, you can see that, basically all it does is it calls a library called referralhandler.saveReferral and redirects out to a thanks page. I didn't write this code, otherwise it wouldn't actually crash, but I don't really know how it works. I don't know why it's crashing. So I want to implement some tracing, so at a minimum I can get a call stack and start tracking down what's going on. So I'm going to add a little bit of snippet of code in the global ASX and application error handler. If you ever use any kind of exception handling blocks, this is really how they implement it. Oops. This is a global exception handler that basically will catch every unhandled exception. See, all I'm doing is I'm getting the last error that was handled, and I'm calling trace error and passing that exception out to the stream. Okay, so I have another piece of code, 2 other errors that we want to track down, and those are all in the rate quote results.aspx page. And the first one we're going to track down is a service failure. You can see here's where I'm actually calling out to that NT service. It uses name pipes, pretty archaic, but it works occasionally. And occasionally, though, whenever I call into this service, I don't get a response back. So this is where I'm actually setting that error message, no response from the service. What we want to do is add a little bit more instrumentation so we can figure out what happened here. So all I'm going to do is I'm going to log out to the trace writer or trace listener is the input that I'm actually passing that service. That way I can go back to my C developer and say, hey, your service is crashing, and here's what we passed it when it crashed. And we have one more bug. This is that calculate mortgage payment. Occasionally, the monthly payments actually return back as infinite, set to infinity. So I'm sure it's something to do with these inputs, principal, rate, and term. So let's go ahead and add a trace statement for those as well. Okay, so our application's all instrumented. It's pretty much ready. So now we're going to sit here for the next few minutes and wait for it to deploy. No. So just pretend that we actually went through a deployment. We use PowerShell, we use Visual Studio. It's out in the cloud. It's all ready to go. So what we want to do now is actually configure diagnostics to capture all that trace information. So I'm going to flip over to PowerShell and walk you through how you would actually configure this using solely PowerShell. I got some cleaner methods to show you as well, but we're going to start with the basics. So to use PowerShell, first thing we need to do is add the PowerShell snap-in WA PPS commandlets. I actually have an import module here too that I'm importing some helper code because some of the settings that I'm doing take a lot of code. So actually I'm going to post those on my blog later. So if you're curious, you want to replicate it, it'll actually be on my blog. So one function I'm going to show you that is in that helper is a function called getDiagRoles. And while it's thinking, oh, it already returned. Basically, you can see down at the bottom that it returned back all three of the diagnostic aware roles that we just deployed. So you get the name, you get the deployment ID, and you get the storage credentials. From there, we can take that, we can pipe that up to PowerShell's for each operator. And from there, I can get the current role that I want to work with off of that weird PowerShell variable, $_. And I have some code that I'm going to set to actually configure diagnostics. So the first thing I'm going to do is set the Windows Azure trace log. Or the Windows Azure log. Anytime you hear Windows Azure log, think trace log. That's all that goes in there. Anytime you dump out using the trace class, it's going to be in this log. So I need to pipe out the current role to set Windows Azure log. Just think of piping as passing a variable to a function. It's the same thing. With set Windows Azure log, I can tell it which errors I want to transfer over to storage. In this case, I'm really only interested in errors. I can set a quota, or optionally I don't have to, and I can tell it how often to transfer this data over to storage. For demo purposes, we're going to do 1 minute. You'd probably want to do like 10 or 15 later. So that configures Windows Azure logs. Next thing I want to do is configure Windows Azure event logs, so we can actually download the Windows event logs from the server. Pretty much very similar code, except I have to add which logs I want to monitor. So I create an array with application and system. And if you notice the $, this is actually an XPath query. You can write a really complicated query that'll actually only filter down to a certain property in that event log. We're okay with just pulling all the errors, so that's okay. And I'm going to tell it to, just like before, use error, no quota, and transfer in 1 minute. Okay, now here's a big cheat. I'm going to call set perfmon counters, and it just magically works. So set perfmon counters is a helper I wrote. Oh, here it is. It's basically a PowerShell function that creates an array of perfmon counters, and once it creates that array, it calls set performance counter and passes that array and actually configures diagnostics for you. So if you're curious how you get the samples, you can actually type in typeperf-q at the command line, and it'll give you a giant list that you can configure. And of course, this will all be on my blog, so you don't have to actually remember it. Okay, so we've configured Windows Azure logging, we've configured Windows event logs, we configured perfmon, and I'm going to configure logging next. So this snippet of code, basically, as we're iterating through the roles, it's looking for the 2 IIS web roles. So if it's the mortgage rates web project or the PDF generator, then we're actually going to configure diagnostics to transfer over our IIS logs and our IIS failed log requests over to storage. I have this custom logging one as well, but I actually forgot to set that. So just to backtrack a little bit and show you how we set that, if you look at this is back to the WCF service that has its own custom writer. Basically, it's looking for a log directory of where to actually log everything to. And it's by default, it's pulling from some setting you put in the web config. What we want to do is make a resource that's actually managed by Azure. That way we have quota enforcement, and we also have the capability to transfer these custom files out to diagnostics. So to do that, I'm going to open up the service definition. I'm going to add a local resource to that specific worker role. So you can see I got mortgage rates web service, and here's my PDF generator. And all the local resources is basically a named location on the instance file system. So you give it a name, and Windows Azure creates a directory somewhere for you. So I'm going to call this local resource custom logging. And default quota 250 is fine. Okay, and in our trace listener, instead of returning this, we're actually going to return the path back to that local resource. So I'll call get custom logging and root path. That'll take care of our logging. Okay, so back to PowerShell. So we've taken care of perfmon, Windows Azure logs, bitlogs, and logging. The final piece that was in our requirements was storage analytics. So I have a big snippet of code here that's not storage analytics is not tied to a specific role, it's tied to a storage account. So it doesn't belong in the loop. So we have basically 3 calls, one for each service that we're interested in capturing analytics on. Tables, queues, and blobs. And these calls are really big because we're basically enabling every analytics you can set. Logging, deletes, reads, writes, metrics. And if you're new to storage analytics, I'm going to show you what that data actually looks like here shortly, and it'll make a lot more sense once we take a look at it. Okay, so you can hit F5 and hope for the best. This actually works. And it won't. I always forget this. So what I forgot to do is pass the current role to some of these commandlets. And it's popping up wanting information. Almost. All right, so it gracefully failed. All right, so what I needed to do is pass the current role to each of these. All right, try it again. And while that's running, I'm going to start up another script so we can actually analyze some of this data. So I'm loading up my Windows Azure PowerShell commandlets, and I'm actually going to show you a little sample code I wrote that, if you're manipulating this stuff, is really handy to make sure you're doing it right. So if you're curious what your current diagnostic settings are, there's a little sample, print diagnostic settings, that will actually go out and retrieve all your settings and print them back about as pretty as you can get in PowerShell, which isn't saying much. So if the blue is the individual service, the green is the individual data source for that service. So starting at the top, you can see that our mortgage rates PDF generator, we have Windows Azure logs is set to transfer every minute, only errors. You can see the perfmon counters, etc. So we at least know that we made our configuration change. So now that we've actually made that change, hopefully the role instances have had time to read and update. Let's go ahead and pretend that we've had some users out there that have actually reproduced our bugs. So I'm going to go to the refer a friend, and I'm going to pretend to be that user that crashes our server. Okay, crash 1, request a quote. This is crash 2, 7-year arm. You should crash if you get a 7-year arm, just not a good idea. So now we see infinity as our monthly payment. And our last crash is going to be Social Security if we leave it blank. All simple validation problems, but you can use this for actual real bugs later. So on this one, you actually see no response from mortgage rate services. Now the trick is, since there's all kinds of delays built in, there's a 1-minute delay before the instance take the settings and a minute delay before they actually transfer over, we have to wait until that data is actually out in storage. So I'm going to call get diag roles, pipe that up for each again, and we'll just see if our data is actually out there yet. So I'm getting the current role, and I'm going to actually pipe that out to a new commandlet called get Windows Azure log. So if our data is there, this will actually download it and show it in the console window. All right, so we got some data. That's good. So this is our exception. So you can see in the message that we get HTTP unhandled exception. You can see it wrapped, but you can actually see that email wasn't specified was the exception. So at least you got a call stack. You can actually troubleshoot your app now. But you notice we only got one. So we must have been in the interval. We got one message come through, and the other two will come the next time around. We'll see if we got the other two real quick. So we figured out one bug. We need to write some validation code to make sure we're capturing emails. And here's one of the other bugs. This is a mortgage rate service error. So you can see I logged all the input that I sent into the service, and this last comma is probably where the social security number should be, and this is where our awesome C developer just completely blew up and did something wrong. So that's bug number 2. We need to validate that, and he needs to validate his service because that's probably a security bug. And finally, the infinity bug. This is the input that we passed. You can see 250, 4.25, and a term of 0. So probably shouldn't be a term of 0. Let's take a look at the code real quick. And here's where they select 7-year ARM. And you can see someone typoed it and left the value to be 0. So I've never done that. Okay, so that's the gist of tracing. Now, PowerShell is really powerful with not just getting data and showing it on a console. You can actually do some really advanced filtering with it. Now, keep in mind, I'm not a PowerShell expert. I've been learning for the past few weeks. But one of the things I've learned is you can filter data. So I can take the result set and I can pipe it out to the where operator. And I can use the current object and any of these fields you see over on the left, level, message, whatever, you can filter on. So like if I was only interested in exceptions, I could take the message filter and I can do a like on it and only look for exceptions. And that should just pull back the email unhandled exception. So that's kind of nice. I mean, you could actually automate this and look for exceptions and email yourself if you wanted to. It can also use others, so like level 2, that stands for error. I think it's level 5 would be informational. You can pretty much filter on any field in there. Another feature that we've added to the Get Windows Azure log commandlet and all the diagnostics commandlets is the ability to save all this data to the local file system. So I'm going to go ahead and create a file name variable, and I'm going to save all this data in the diag data folder. And I'm just going to kind of give it a name for each one of the logs I want to download. Okay, so that should take care of Windows Azure log. It'll actually just download all the data that we transferred over to storage. Oops. So I'm going to download the Windows event logs next. Change my file name. It's WA event log, Windows Azure event logs. Not to be confused with Windows event logs, which are the same thing. And we're going to download our perfmon data next. So instead of being a CSV, though, I'm going to name this BLG. And I'm going to set another form, got to change the commandlet. All right, that should take care of the logging that we've actually set. So I want to go ahead and download our actual logs, RIS logs as well. Oops, this is the wrong one. So I'm using 3 commandlets, save container, and just having them download all the contents of those containers to the local file system in diag data as well. So let me go ahead and run this and see if I did everything right. So it's working on something. That's always good. All right, so let's jump out to the diag data folder and see what we have. Okay, so we have BLG files, we have some CSVs, and let's see. So here's our mortgage rate service event log. You can just open that right up in Excel. And you can see these are all the event logs, and we can see that the reason the mortgage rate service wasn't responding is because it actually crashed. So that would be an issue. We'll have to figure out how to debug that. And you can also look at your trace logs, just like before, and see the same errors that we saw in the console, except you can use this for offline analysis. And finally, you can actually open up your performance data and see how your CPU utilization, your memory consumption, all that good stuff is going. And you can do this all in an automated fashion. So you could literally write scripts, download your data, analyze it, et cetera. And one last thing I'm going to show, but I'm not going to do because I got another toy to show, is how you can actually clean up this data. So I have a little snippet of code. If you've jacked up your perfmon counter settings all the way high and you want to turn them off for some reason, you can actually clear out all the settings. So this little command, or this little script right here, basically each one of the arguments has a -clear parameter that resets the settings on it. So that's how you could actually reset, start from scratch. If you wanted to actually delete the data out in diagnostics from storage, we have another set of commandlets. Basically, for each log data, we have a clear command. So you can clear the Windows Azure log, event log, infrastructure log, etc. And you can also clear out containers too. So you can manage all your storage containers from PowerShell as well. But I'm not going to do that yet because I want to show you one of our partners' apps. This is Sarah Brada's Diagnostics Manager. So as you can see, I have all my hosted services that you saw out in the portal are out here. I can go to the mortgage app that we were working on, and the same things that we did in PowerShell, I can actually go into remote diagnostics through their app, pick whichever instances I want to work with, and for each instance, I can actually go in there just from a nice little GUI and actually configure all the diagnostics. So you can see all the perfmon counters. We can add new ones. We can schedule the transfer, change the sample rate. Same thing for Windows event logs, etc. And you can actually configure all this once, and apply it to all the instances, or you can actually do each instance type independently, or each role, I should say. So just like they give you the capability of configuring the data, they also give you the capability of analyzing the data too. So I can go into trace logs and tell it, show me all trace logs in the last 2 hours, and go into get data, and you can see those trace logs that we logged. So you can see the mortgage rates error, the calculate mortgage payments problem, and the exception we threw. So very nice tool set. They actually have some dashboard capability too that'll actually pull Windows Azure storage and give you a dashboard of how your application works. Okay, so I think we're through with that demo. Sure. It deletes everything in the container. Depends on how much you have. Could take a while. Mm-hmm. Right. Okay, so the question was, sorry about that. The question was, how long does clear container take? And it all depends on how much data you have. So if you have a really big container, it might be good to have it scheduled and maybe just do batches at a time. I'm trying to remember if you can or not. I don't remember if we did that. Let me see. And you can do a filter, so you could delete file types, but you can't actually do date ranges on that. So the question is, how would you actually delete the first 5 months? Well, what you would probably want to do is start over, download all that data to your file system, clean out the entire container, and work on a scheduled system. So you download the data, clean the data, download the data, clean the data. So it's not really designed for, basically data mining or diagnostics. It's really meant for automating how you manage your diagnostics data. Right, that's true. So there is a chance if you do this that we could miss it. I'll have to think that one through. So follow up with me, though. I'm sure I can figure something out for it. So let's talk about debugging Windows Azure apps. So we've already talked about capturing all the trace logs and event logs and all that good stuff. How can we actually debug those really hard to deal with crashes? The first question you have to ask yourself is, where does your code actually run? If you're to launch the debugger, what would be the process name your code would run in? So here's a little diagram that basically tells you a good overview of where your code would live. If you're an ASP.NET app and you're running in full IS mode, you have basically a sites element, your ASP.NET code would run in the W3WP process just like normal. If you have code that's starting in a worker role or starting in your onStart method for your web role, that actually does not run in the W3WP. It actually runs in WAIS host. So that's one area where you really just have to be careful about trying to access data from either process. If you're running ASP.NET and you're using hosted web core, this code all runs under WA web host, the worker role initialization and your actual ASP.NET code. For worker roles, if you're just a pure managed code, pure C# and you're running a worker role, all your code will actually run under WA workerhost.exe. However, if you have a little bit more complicated solution, like starting services or starting COM+, you always have to remember that even though you have a worker role, that code, if it's running on a process, will be running somewhere else. So how can you, now that you know roughly where your code's running, how can you actually debug these unhandled exceptions that happen in your app? So your first line of defense is going to be exception handling. Make sure that you are using some kind of exception handling framework, ELMA, or one of the patterns and practices exception handling blocks. Make sure that anything that can throw, you catch it, you log it. Make sure that you also are using informational logging. So if you have logic errors, that you can actually enable your logging and see what your application is doing. Other tools, one of them is crash dumps.enable collection. This is part of the Windows Azure diagnostics. Basically, what it really does is whenever you start up your worker role, you can enable collection, and it'll automatically catch crash dumps for you. Now, the downside is it really only works well with worker roles. It does not work well with ASP.NET. And if your worker role spawns other processes, it's not going to handle them either. So Visual Studio IntelliTrace is a great tool for tracking down crashes, stuff like that. For 2010, it's not really supported to run in production. For 2011, it will be, though, so that's something you can always think about. What it really does, it actually allows you to go back and replay a crash. So you can back up in a call stack, look at your local variables, and do all kinds of really interesting debugging to figure the problems out. Now, the downside to IntelliTrace is it's managed code only. So if you have any C++ code or anything like that, it's not going to help you out with those. So for fallback, when all else fails, when all the other fancy tools don't work, you still have the traditional tools, tools like 80+, Debug Diag, WinDBG. If you've never seen those, count yourself lucky. But those tools are really the last resort debugging really crashy, buggy errors. So Microsoft developers use them extensively. Microsoft escalation engineers use them extensively as well. Sure.
How much does the IntelliTrace slow down?
The current one, enough that you wouldn't want to run it in production. So you would really only want to do it in development or staging to track down errors. 2011, there was actually a session yesterday talking about using it in production. So if you didn't see it, you can go hit it on recording. She did a good job. So performance problems. Some of the tools that you can use for tracking down perf problems are perfmon counter data now. Make sure that you're logging perfmon data. Make sure you're getting a baseline of how your app works under a normal load. And then you can actually monitor this using perfmon to see if there's been any increase or decrease in the changes to your app. You can look for bottlenecks in CPU, disk, etc. One of the neat things that I've actually done with PowerShell is since we can download that data, you can download it as BLG, but you can also download it as a CSV file. You can literally write a PowerShell script that would go get the last 2 hours of perfmon data and calculate your average CPU and generate alerts for you. So it takes a little bit of extra scripting, but it can be done. The Visual Studio Profiler tool we've released in the 1.4 SDK tools. This is really great for tracking down inefficient code, memory leaks, hot areas in your app where basically you're hitting the same code over and over. Maybe you should take a look and see if there's anything you can do to optimize it. And conditional tracing. So conditional tracing is a method of putting tracing in your application that you can turn on and turn off dynamically. So if you're familiar with SharePoint, they do a superb job of conditional tracing. Basically, that you can start from literally no tracing all the way up to verbose where it logs an entry for every little thing it does. And how you could do that in Azure is basically use Windows Azure configuration for setting trace switches. You could say trace this method, trace this, whatever. And you can turn them on, turn them off through the portal to trace the output of your application. I have a little snippet of code just to kind of give you an example of how that would work. And finally, storage analytics, which I completely forgot to show, but I will. Storage analytics gives you metrics, capacity data, and raw log entries on how you're actually using Windows Azure storage. So if you have a piece of code that's using storage and maybe it's not as performant as it could be, you might want to enable an analytics and start analyzing all the requests to those containers to see how you're using them. Okay, so this is a code snippet I was talking about that basically allows you to read a configuration setting out of Windows Azure, which is using role environment.get configuration setting value. Assuming it's set true or false, you actually could do some additional tracing here. So all this one does is it creates a stopwatch cost and basically allows you to time how long a function actually took to operate. Be really good for tracking down database queries or file I/O, something like that. Okay, and if you've ever wrote startup tasks, they're tricky. Here are some tips for troubleshooting startup tasks. Definitely not inclusive. It doesn't cover everything. I'm sure there's 30 or 40 more of them. The first thing you need to understand when you're doing startup tasks is understanding the architecture, which one you would actually use. A startup task marked simple, all that really means is your role instance is actually not going to start, it's not going to do anything until that startup task is complete. So it's really good for setting up the environment that your role depends on to use. However, obviously, if it doesn't ever complete, your role instance isn't going to start. So good thing to keep in mind. Foreground and background startup tasks are the other two methods. The difference between the two, they both run in the background, so they'll run concurrently along with your application. The difference is the role will actually not be able to shut down and recycle until the foreground task is complete, or the background one when it can. So that does introduce some concurrency issues, though. So if you're trying to configure stuff at the same time your role instance is starting up, you'll have to think about ways to synchronize those. Other methods, if you have batch files that you're using in startup tasks, make sure you log the output. That way, if it fails, you can just RDP out to the instance and look and see what the actual output of your command was. If you're like me and you use the PowerShell for deploying startup tasks, every now and then you'll use some fancy PowerShell feature that's not supported in the 1.0 release, and you'll get really weird errors. It'll show, the $ is not supported or something like that. Usually the answer to that is bump up OS family equals 2 in your configuration, and it'll actually move the role instance to be in Server 2008 R2, which uses PowerShell 2.0. And finally, or not finally, almost finally, if you're adding content to your project and you try to build it and package it and it gives you errors that can't find content, make sure that you mark all the content as copy always, or it won't actually include it in a package. And if you weren't aware, make sure that you are aware that all your Azure roles, you can actually enable remote desktop and actually just RDP remote desktop out to and actually try your startup task locally from the E drive. One thing to keep in mind, if you go out there on E drive and you start your startup task and it works beautifully, but whenever it went through in your app and it didn't work, so there's a really good chance it's going to be a permissions issue. Whenever you log in, your logged in is elevated. By default, your startup task is not going to be elevated. So if it's accessing stuff like registry, that could cause a problem. But good news is you can always mark your startup task as elevated. And finally, if your startup task is hanging, it's a batch file, make sure that you have exit/b0 at the end, just because that's the only method Azure actually knows that your batch file is complete. So I'm going to walk through call it the worst case scenario of debugging an issue. So let's assume that the mortgage rate service that we had, it's a native service written entirely in C, NT, really old, crunchy code. Let's assume that our tracing code didn't tell us what the problem was, and we really just had to fix it because it crashes every now and then. And our developer says, the only way I can do it is if I get a crash dump of it. So I'm going to walk through that worst case scenario of actually how we would get that out to the cloud and capture a dump. So I should probably switch. So here is the mortgage rate service. And what I'm going to do is I'm going to deploy the entire debugging suite out to the cloud and use it to attach to my rules engine service. So I'm going to go ahead and create a new folder called debugger, because you actually have to deploy the debugging tools to do this. There's probably an easier way. You could probably zip it up and actually run a silent install, something like that, but it seemed pretty straightforward. So let me add, these are basically all the files from the debugging tools for Windows folder. Oops. So to get these to deploy with your project, once you've added them, you have to basically select all of them, mark them as build action equals content, and copied output directory equals copy always. So now, whenever you actually deploy this project, they'll go with you. So the next thing we need to do is add a couple of files to the startup folder. So I'm going to add a batch file called crashmode.bat and a PowerShell script called start80+. If you look at crashmode.bat, all it really does is it kicks off my PowerShell script. It asks what resource I need to dump the dump files in and what process to actually debug. So I'm going to tell it the rules engine service. And I need to include these with the project as well. All right, so now I need to hook the startup task up so it actually executes when we deploy. And this would be back in the service definition under mortgage rate service. I already have a startup task called startup.cmd, so I'll just add another one. And this will be a background task, and I'll show you why in just a second. So the PowerShell script, how it actually works, is it basically gets your resource directory where you want to dump the file to, gets your file name, and it waits in a sleep pattern until that service is actually up and running. Once it detects that it's running, it attaches immediately. And it attaches in crash mode, which means the minute it finds an unhandled exception, it's going to just do a full dump out to the file system. Okay, so now let's pretend we actually deployed this, and it's all out in the cloud now. And you can see I do have it deployed out there with the debugger set up. So I'm going to RDP out just to show you what it actually did. All right, so here's our mortgage rate service. And you can see the very first item in the task list. I don't know if you can see that, but it's cdb.exe. That's a command line debugger, and it's attached to the rules engine service. It did create a folder for the local resource. If you're curious where local resources actually go, they go under the C drive, resources, and right here. So here's the custom resource I created, crash resource. And you can see that 80 plus is ready, it's initialized, it has its log files. It's just waiting for a crash to occur. So I'm going to go back over and oblige it by crashing it. So I'll go through the same bug that we were talking about earlier. And behind the scenes, it actually threw an exception. The debugger attached, it was already attached, and it's actually dumping out the dump file. So the only thing that would be left for us to do would be to use PowerShell or Cerebrata or Azure MMC to actually transfer this from the local file system out to storage. And that's how we could actually track down these are the ones that you hope you never have to have, but they do happen occasionally. All right, so I'm going to backtrack a little tiny bit and just show you the storage analytics piece. Okay, so we did set this to all log the data, so I can go into Windows Azure, and first thing I can do is I can actually call get storage analytics settings, so I can see what my current settings are. And basically it just takes a storage account name and which service you actually want to use. So I can call this. I think we're formatted as a list. Yeah. So you can see for each service we're logging deletes, reads and writes. We have a retention policy. So storage analytics is actually really nice because you can set a retention policy and it'll delete the data after that. We also have metrics. I'll show you what that data looks like here in just a second. And we have that for each service. So we can enable it, we can get it, and we can actually, from PowerShell, we can download that data as well. So you have a lot of options when you're saving storage analytics. So if you're looking purely at blobs, Blob has 3 different data types you can access. You can actually download the blob pure log data. So every request that goes into your blob store, you can download that. And our PowerShell commandlet actually converts that over and puts it in a log file. It's not comma separated, it's semicolon separated, so you have to do a little parsing. So it downloads all the raw log data for blob tables and queues. And for Blob specifically, they also have a capacity element. So you can download metrics that tell you how much blob storage your application is actually using. And the rest of them all have transactions and just a raw data. One final thing is we actually do some data manipulation. So we take your log entries and we put them in a file. If you want the raw data, you can actually just use save container and specify the container name. You have to escape the $sign because it's a PowerShell special keyword or character or whatever, and you can actually download the raw blob data out from the file system. So I've actually been running this for a full 5 days, and it takes a long time to download. So let's just pretend we downloaded it, and I can actually show you what some of this data looks like. This is some data I downloaded a couple of days ago. And I can open it all up in Excel. So here is the raw queries to the log. Of course, it wants to know how it's delimited. So I'll tell it semicolon. And you can then go into, and you can see when their transaction actually started, what type of request it was, whether it was an error, success. You can actually see the raw URL, etc. So you can use storage analytics to get a really good insight into how your application is actually using storage. This is kind of the FileMon for the cloud. Other data types that you get from Windows Azure Storage Analytics is capacity. It's basically a really short data file. It tells you how much storage you're actually using, how many objects you have. You can see I'm not using a whole lot of storage. Actually, analytics is taking up more space than the actual data I have is. And finally, capacity is only for blobs as well. And transactions gives you basically all the metrics there's tons of metrics, tells you latency per request. And there's a Get MSDN article that explains what all these different metrics are. But you get the total requests by user, how many are billable, how many were successful, what the average latency is, etc. Okay, so that takes care of storage analytics. So just to wrap it up, some other resources. Obviously, we just shipped the Windows Azure PowerShell commandlet, so if you're all really excited about PowerShell, you can hopefully go download those today. We'll have some blog posts, some code samples. Everything you saw in the demos, we're going to have up as examples pretty soon. A couple of other examples that are really good from a debugging perspective is Steve Marks has created a couple of examples where you can actually just capture an exception and dump it directly to blob storage. You don't actually have to worry about waiting for it to transfer or any of that stuff. It's much cooler for just pure debugging. You can also do the trace listener directly to storage tables. So you can pull up any of the storage tools out there and just pull those up to see what the latest trace date is. If you're curious and you want to instrument your application further by using configuration, there's an article in the June 2010 issue of MSDN that very, very thoroughly detailed about using trace sources, trace switches, and configuration that'll tell you exactly how to instrument your app end-to-end with Azure. If you have Operations Manager, System Center, take a look at the Azure Management Pack for Operations Manager. Basically, it allows you to do diagnostic monitoring, diagnostic configuration, takes care of all your data analysis end-to-end. And the link I have there basically takes you to a VHD with a trial license on it, and you can actually give it a shot and figure out how it works. And finally, the app that I demoed is from Cerebrata, Diagnostic Manager. They have a bunch of other great tools that you can use for Windows Azure managing your environment. They actually have their own PowerShell commandlets too that are really nice. That's it. Done. Any questions? Awesome. Thank you very much.